All right, so let's go on to about fish. So let me first start by asking you, is a starfish a type of fish? So go ahead and make your guess. Is a starfish a type of fish? So starfish are not fish. They are actually what we call sea stars. To make it a little less confusing, starfish are not fish. They are invertebrates, so they have no backbone. All right, now let me ask you this. Is a shark a type of fish? Like these two right here. Are these fish? Sharks are actually types of fish. And my last little before question is a dolphin a type of fish? So guys, a dolphin, is that a type of fish? All right, guys, so the answer is no. Dolphins are actually mammals. They are not fish. So let's go ahead and talk about what is a fish. So a fish is gill-bearing. It's aquatic, so it lives in the water. It does not have arms or fingers. They are ectothermic, which means that they're cold-blooded. So the temperature around them determines what their body temperature is. So kind of like reptiles, how they need to sit out in the sunlight to get warm. They're ectothermic, so they're cold-blooded. Fish also have a vertebrate or a spine, so they have a backbone. Remember, our corals are animals, but they don't have a backbone. Sea stars, sponges, they're all animals, but do not have a backbone. So again, guys, fish have backbones. So when I say fish, I'm not talking about shellfish or cuttlefish, starfish, crawfish, or jellyfish. Those are not fish. All right, guys, so really briefly to talk about the outside parts of a fish, let's go ahead and hopefully you guys can see this pretty well. But when we talk about a fish, they have a dorsal fin on the top there. They have a caudal fin towards the back. Let's see, there we go. And their side fins are going to be their pectoral fins. Their gills are going to be right here, and they have an eye and a mouth. So there are two main kinds of fish. So the first one are going to be your chondrichthyes. Everyone say chondrichthy out loud. Your chondrichthyes are going to be these friends right here, your stingrays and your sharks. So they are chondrichthyes. They're made out of cartilage. So everyone go ahead and feel your ear. Your ear and your nose are made out of cartilage. And that's very, very flexible. So your chondrichthyes, your sharks, and your rays, their bones are made out of cartilage. So they're very, very wiggly. That means their organs aren't very well protected. Another thing about chondrichthyes is that they have gills that you can see, and they do not have a swim bladder, and we'll talk about what a swim bladder is a little later. Now your osteichthy fish. So guys, your osteichthy fish, everyone go ahead and say osteichthy, are going to be fish kind of like this. So when you think of fish, when you hear the word fish, probably what you actually imagine. So these are going to be the fish that you kind of imagine when I say this. So say osteichthy. Now your osteichthy fish are going to be made out of actual bone. So that's the biggest reason why they're different from sharks and rays is that your osteichthy fish have bones like us. Your chondrichthyes have the cartilage bones. Also, guys, your osteichthy fish, they do have gills, but they're actually covered by an operculum, so you can't see it. And later on during our dissection, I'll actually show you what their gills look like. And your osteichthy fish have a swim bladder. Now, when we talk about fish, we talk about 5 main things. We talk about their body shape, their mouth location, their tail, their color, and anything else that might be special about them. So we're first going to talk about their body shape. So guys, if you have worksheet 1 or 2 right here, go ahead and pull these out. You can do one, you can do both, you can do none. That's totally up to you. But what you're going to be doing is matching the term with the shape and the species. So this is the actual fish species, and this is the actual kind of common shapes that you know about. So I'll be mentioning them while I introduce each body shape. Again, if you don't have a worksheet, totally fine. You can look at it later and practice. So let's go ahead and talk about our body shapes here. So guys, these are the different kinds of body shapes. So the first one we're going to talk about is your fusiform body shape. So your fusiform is up here. I say fusiform football fast. So if you guys want to say that out loud, say fusiform football fast. Your fusiform fish are going to be like your tuna. So they're going to be more football shaped, kind of like that if you guys can see it. There we go. So just like that. They're pointed at both ends. Now let me put a poll up for you guys. So do you think the fusiform body shapes are going to be fast swimmers? So again, do you guys think that the fusiform are going to be fast swimmers? So they look like a football. Tuna is a very good example of them. Okay, awesome. So guys, the fusiform body shapes are actually very, very fast. So your fast fish swimmers are going to be usually having a fusiform body shape. All right, guys, the next one, I want everyone to kind of put their hands together and say compressiform. Your compressiform body shapes are going to be very, very narrow, but tall. So very skinny, but tall. So it's going to be things like here, your angelfish. They kind of look like a book. So I would say a book is a good way to remember these friends here. And your angelfish is a very usual person or fish that has a compressiform body shape. So again, guys, your compressiform body shape looks kind of like a book if you're staring at the spine of a book. And your angelfish are going to be one of those especially. All right, now everyone push down on the ground and say depressiform. So depressiform body shapes are going to be the ones that are flatter and kind of more towards the ground usually. So these are going to be your depressiform body shapes. All right, so they're flat, but they're kind of wide. Usually you're going to see these hanging out near the ground, or most of the time, at least their food's going to be on the ground. All right, so now we have globiform body shapes. So we're up here again. Everyone go ahead and say globiform right there. All right, so guys, I'm going to post another poll for you. Do you think fish with a globiform body shape, so this right here, do you think they're going to have or be very good swimmers? All right, guys, good. So the answer is no, they're actually not very good swimmers. Because of that, they've had to evolve to adapt to this bigger, rounder shape to protect themselves. So pufferfish, they don't always look like a big soccer ball or a basketball. They usually look a little bit different, but when they are scared or threatened, they can't really outswim a predator. They're not very fast swimmers. So instead, they'll expand to that bigger shape to protect themselves. So it's easier for them to get eaten. All right, guys, so your next body shape is going to be sagittiform right here, or your arrow shaped, okay? So they look more like an arrow. One example I have for you is a barracuda. So barracudas, they're pointed at one end and they kind of flare off with their tail. So your sagittiform body shaped fish are longer, so they don't really look like a football. And they are ambush predators. So they usually you'll find them kind of sitting and hanging out, waiting until they see something that they really want to eat. And then all of a sudden they'll quickly swim after it, eat it, and then they'll kind of hang out again. Usually your sagittiform body shapes have toothy mouths. So these are a very good example of one. Tarpon, if you know what a tarpon is, that is also a very good example of a sagittiform body shape. All right, guys, now we have a few other body shapes to talk about. So we have what we call anguilliform. So anguilliform here, like this moray eel. So the moray eel, I kind of explained that it looks like a windsock. So a windsock is something that you see at airports, and it talks about the direction of a wind. It kind of starts a little bit bigger and then points off like that. They're very flexible, and you'll find these guys hanging out in holes. All right, the next one we have is filiform. So filiform is more thread-like, so they're like thread. So they're much more narrow and smaller, like the sea snake here in the Pacific Ocean. This one right here is going to be your ctenoform fish, so like your oarfish. They are more ribbon-like, so you'll see them. They're a little bit more flexible than your eels, than the anguilliform body shape. So your ctenoform body shapes are going to be more ribbon-like. Let's go ahead. and move on. But first, I want you guys to know that even though we have these body shape categories, they don't always fit into the same category. So this one right here, what we call the blobfish, that one obviously doesn't really fit in any type of body shape. So there's going to be a lot of fish that don't exactly fit into one of these categories that I told you about. So just keep note of that. And my next example will also be one of those. So let's talk about their mouth shape and location next. So we'll first talk about fish with a small mouth. So an example is a seahorse. So a seahorse is a type of fish. Again, it doesn't have a body shape that really matches anything else. But this seahorse has a small bill-shaped mouth. So what do you think a fish with a small mouth would eat? They will eat smaller things. They don't eat big things. It's just not very possible for them. All right, guys. So let's talk about fish with bigger mouths. So here, this grouper has a big mouth. They're going to be eating bigger things. So your fish with big mouths are going to be eating much larger objects. Alrighty, so let's talk about fish with downward facing mouths. So this fish here is a nurse shark. Its mouth is towards the bottom. So what do you think a fish with a downward facing mouth would eat? Very good, guys. So they're going to be eating things more towards the bottom. That's where their mouth is. It wouldn't really make sense for them to eat things that's on the top because then they have to roll all the way over, and that would be a little silly. All right, then we have fish with a beak-like mouth here. So you see this parrotfish. They have a beak, almost mouth, and that's why they're called the parrotfish actually. So they have that mouth and it helps them crush things. So I mentioned this before, but parrotfish will eat a lot of the limestone that the corals build. They'll eat the algae as well. So that'll help them eat. So your beak-like mouths are going to be eating more stronger things, and they're built for crushing. Then you have fish with an upward-facing mouth. So your fish with an upward-facing mouth, like this tarpon here, they're going to be eating fish towards the top, like minnows, bugs, other things hanging out towards the top. So now let's talk about tail or caudal fin. So when I say caudal fin, I am talking about their tail. There are quite a few main types of caudal fins. So I'll break it down for you guys. The first one we have is a rounded caudal fin here. So you're rounded, pretty easy to remember. You have fish with a truncate tail here, so it's flatter. Think of a trunk, like like in Harry Potter is a box, so it's more squid off, if that helps you. An emarginate tail, these, I don't really have an easy way for you guys to remember this. It kind of looks like a truncate tail with a little bit of an indent in it, so your emarginate tail here. You've got your forked tail, so think about a fork in the road. That's an easy way to remember one. Then you have your lunate tail. I think of a moon when I hear the word lunate, so I think of a crescent moon. Then you have your heterocercal tail. So your heterocercal tails are going to be for your sharks only, really. Your sharks have these tails that aren't very symmetrical. So it's longer on top, smaller on the bottom. So guys, out of these five here, out of the rounded, truncate, emarginate, forked, and lunate, which one do you think would be the fastest? All right. The answer is actually lunate. So your fish with a lunate tail is actually going to be faster. So think about tuna. They don't have a big tail. It's very skinny and small because it's very muscular and strong. So it is a little confusing to think that the smallest tail is the fastest, but that's less water that they're going to have to work against, and they can move it quicker and quicker. So your lunate tails are going to be your faster tails. All right, guys, there's some other extra things about like their colors, for example. So we have fish with what we call disruptive coloration, like these sergeant majors. And the reason that a fish might have this type of coloration is because it's just confusing. So with all these stripes and different colors, and when they hang out all together, it can confuse a predator and makes a predator not really sure where their fish that they want to eat is. It's going to be a little disorienting. You also have what we call counter shading. So counter shading is when they're lighter on the bottom and darker on top. A lot of your open ocean fish, a lot of your sharks and rays have this coloration. And the reason that this coloration is actually important is because it's like camouflage with the sunlight. So it's lighter on the bottom because if you're looking from underneath, it actually will blend in with the sunlight. If you're looking from the top, it's dark, dark top blends in with the darkness of the ocean. So again, guys, if you look down, it blends in with the deep ocean. If you look from underneath, it blends in with the sunlight. So this is a very, very popular coloration that a lot of animals in the ocean have. So they're camouflaging with the sunlight. You'll also have fish that'll just go through camouflage. So a lot of flounders, for example, will camouflage with the sand to blend in. There are certain species of seahorses that will camouflage with the coral. This one right here is what we call a fake eye. So its fake eye is here. Its real eye is there. This is a type of butterfly fish. Now, guys, most fish that have this are going to be smaller. And the reason is because, one, this eye looks a lot bigger than its real eye. Also, it can look like two eyes are looking straight at the predator. So it makes the fish look a lot bigger. And finally, because they have that fake eye towards their caudal fin or their tail, if a predator tries to eat them, the predator is going to go for the tail and not the head. So this fish has a better chance of survival. So a lot of smaller fish will actually have a fake eye. There are some other special adaptations that fish will have. So some fish may have thicker scales, so that will protect them as well. So a lot of tarpon actually have very thick scales, and freshwater fish. You'll have fish that have spines. So I'll show you one really popular example. Down here in the Florida Keys, we have what we call a lionfish. So a lionfish has all those venomous spines. So a lionfish is venomous. It's not poisonous, so you can actually eat the fish once you get rid of those spines on top. But this lionfish actually is supposed to live in the Pacific Ocean, but somehow, some way, it actually made its way into our waters here in the Atlantic. And because of that, it's actually called an invasive species. So an invasive species is a species that isn't supposed to be here and is doing more harm than good. So these lionfish actually will compete with our fish. They'll eat all the smaller fish. They take over the habitat. They're really not good in our environment down here. So we actually have a lot of initiatives that try to remove them. But lionfish, they have those spines. A lot of other fish will have spines too. Some other fish will take what we call schooling. So if you guys have ever seen Finding Nemo, you might remember the scene where there's all those fish and they start making shapes to show Marlin and Dory which direction to go. Smaller fish are going to be schooling more. It's more power in numbers. So if a predator does come, then there's a higher chance of survival. So a lot of your bait fish, especially like your minnows, your mullet, things like that are going to be schooling. We also have 4 different types of scales. So this might be hard for a fish dissection today to find out. Some fish is easier when they're bigger scales, but your Ostia Kleefisch bony fish are going to have either ctenoid or cycloid scales. Your cycloid are just more rounded scales. We have ganoid scales here, but they are really only with your freshwater fish. So we don't really see them down here in the Florida Keys, but you guys more in the mainland definitely would have some of these fish with ganoid scales. Your placoid scales here are going to be with your sharks and your chondrichthyes more. So they're called dermal denticles because they actually look like teeth, so like skin teeth. If you guys want to learn more about sharks and chondrichthyes, Miss Alex is actually going to be teaching you guys all about sharks on Friday. So that'll be a really good lesson. All right, guys, so those are the scale types. All fish, chondrichthyes, osteichthyes, also have what we call a lateral line. So this is a snook, and it's a very good example. If you all see that black line right there, that is the lateral line. So go ahead and say that out loud. So the lateral line is something that we as humans don't have anything like. So the best way that I can explain this is imagine that you can close your eyes, but you can feel everything moving around you. And that's what the lateral line does. It helps them feel things without having to see them or touch them. So I could feel something without ever having to touch it. So think about maybe that our fingers had superpowers, and I could touch something without ever having to act, or I can feel something without ever having to touch it. And that's what a lateral line does. So all fish have a lateral line, and that helps them feel what's going on in the water. It helps them feel predators, prey. It helps them not run into things. So if a fish didn't have a lateral line, they would just be really clumsy and bumping into everything, and they'd be a little goofy. So this is very, very important. And again, we don't have anything like this, but if we did, it'd be pretty cool. All right, guys, so your Ostia Kleefisch I mentioned have what we call a swim bladder, and it's kind of like a balloon almost inside of their body, and it gets bigger and smaller as they go up and down in the water. So it just helps them go up and down. That's pretty much it. They fill it up with water, and they release the water as well. When we do our fish dissection, we're not going to be able to see it probably just because it's going to be smaller because it's not alive anymore. If you're going to be joining the fish dissection, just hang on for a second. I'll be starting the video for the dissection in just a few minutes. All right, guys, so we're going to be dissecting a Bonita today. This is Captain Mike from Island Time Charters. He's going to be helping us out today. So this is a Bonita. It is related to a tuna. So it's an open ocean fish. Right there, you see that pectoral fin he just lifted up and the dorsal fin on top. His tail is a caudal, or his caudal fin is going to be a lunate tail, so he's definitely a faster type of fish species. That coloration is going to be counter shading, so remember it's darker on top, lighter on the bottom, so it blends in with the light in the area. I'll get closer and you can actually see that lateral line. So remember, the lateral line helps them feel all the movement and vibration in the water. So it helps them detect what's going on. All right, guys, so remember I did say that on your Ostia Kleefisch, you can't see their gills from the outside. So can you go ahead and lift up that operculum there? So the gills are actually going to be hidden underneath. So you'll see that. We'll pull one out at the end. So go ahead and close that. So you guys see that operculum is very, very hard. It's going to be like a cover over it. And then can you go ahead and open up the mouth for me, if you can? So that mouth is very small. And you guys can see, yeah, it's very small. So you're not going to expect it to eat a lot of big things. You're going to expect it to eat smaller things. And you see it's got very, very tiny, tiny teeth. All right, so you can go ahead and start cutting it open and we'll pull out. Yeah. Yeah. All right, so Captain Mike's going to go ahead and start cutting the fish for us so we can look what's inside of it. We'll look at the stomach, see if there's anything in there. We'll try to pull out the liver and the heart. So guys, the Bonita isn't a very popular fish to eat. They do eat it in other countries. It's not very popular down here in the Florida Keys. There's definitely a lot of them down here. And they're usually used for bait. So when people go fishing for bigger things, they use the Bonita as more of a bait fish. As that fin down there is going to be called the anal fin. So it's towards the back. And remember that dorsal fin is on top. And the side fins are going to be the pectoral fins. So if you guys are working on that worksheet, you guys can label part of those things there. All right, guys, so there is a question that says, based on the mouth, what do you expect to find in its stomach? So go ahead and fill that out, and then we're going to try to see and look on these Bonita fish. Sometimes don't really find much in their stomach just because they do eat smaller stuff, but go ahead and make a guess. All right, so let's go ahead and pull that part out in the stomach. So actually hold it out. There we go. So that's part of the stomach there. You want to grab it out and we can try to break it apart and see. So the gallbladder is connected to that stomach. It's that green thing right there, if you can see the color change. So that's actually the gallbladder. All right, guys. So all these things are kind of connected to each other. It's kind of interesting with a fish. All of their organs are kind of put in one spot. Now, again, we're not going to see the swim bladder today. That swim bladder is going to be pressed up to the spine more so. So again, guys, we're not going to really find the swim bladder today. It's going to be deflated. And then the kidneys are going to be right next to the swim bladder. So we're not going to be able to pull out the kidneys. But for those completing the worksheet, the swim bladder and the kidneys are going to be right next to that spine. All right, so here we have the stomach contents of the fish. So right here is going to be the gallbladder. Alrighty, and right here is going to be part of the liver. And then will you just try to cut out the stomach and see if there's anything in it? I don't think we're going to find much. It looks a little small, so probably wasn't too full. But we'll try to see if there's anything in there. Yeah, see if there's anything in there. Doesn't look like too much, but that's part of its stomach right there. So if you want to go ahead and now, you might have to pull out and grab the heart. So you have to dig in a little bit more. Sometimes it helps if I just cut in there. You might have to do that. All right, guys, so we're going to grab the heart out for you. So I want you guys to go ahead and put your hand in a fist and hold it to your chest. And that is actually the size of your heart. So if you think about this fish and if it balls up its fin, it's really not going to have a big heart you would expect. That heart is going to be found really close to the gills, so it gets the oxygen. So again, guys, go ahead and hold that hand in a fist for me like that, just like this. All right, while we get that heart out for you guys, I will also tell you that, you know, fish do have brains, and their brains can tell you a lot about that organism. We are not going to get the brain today. You actually have to get a special tool. They have very, very hard heads, so it's very, very difficult to get that out there. But if I could get out the brain, you could get a little tiny bone, what we call an otolith. So an otolith is located in their brain, and if you look at it under a microscope, you can actually count the rings on that bone, and you can actually see how old that fish is. Just like a tree, and you can count the rings. So a lot of scientists will actually get the otoliths out of certain species to learn more about its life. So guys, there's a lot of, it's really hard to get the heart out because it's so far underneath the gills. Again, it's for protection. It's also got a very hard head. That's the most important organ for the fish's body, so it needs to make sure that it's protected like that. There we go. All right. So guys, if you want to go ahead and pull out a gill for the next thing. All right, guys, so this is the heart. I'll try to put it under light so you can see a little better. So that's the heart right there. It's kind of interesting to see how big the heart is on this little fish. If you imagine its flipper, or its, not its flipper, sorry, its pectoral fin balled up in a fist, you probably would expect it to be much smaller, but our fish actually have pretty big hearts compared to their body because they have to pump all that oxygen through their body, through their blood. So that's very, very important organ for them. Again, they definitely need it close to their gills to provide the oxygen that it needs. All right, guys, so now we're going to try to get some gills out for you guys. So, again, fish don't have lungs. They have gills, and those gills actually absorb the dissolved oxygen in the water and help regulate and give it through the entire system. So, guys, you'll be learning about this in a water quality lesson later on in one of our talks together. But dissolved oxygen is literally just oxygen that has been dissolved in the water. So think of the name for water, H2O. All right, that O is oxygen. So that's how they will absorb it. And their gills are very feathery and thin to help them do that. All right, and just the final thing is the lens in the eye. All right, so guys, if you look here, these are what the gills look like. They're very feathery. They kind of look like a broom almost. And again, those help them filter out the dissolved oxygen in the water. So these gills are very important. Again, fish don't have lungs. They have these gills here to help them. So that's really, really cool thing that these fish have. All right, guys, so finally we're going to be looking at its eyes, and hopefully we're going to find something really, really cool. So can you try to pull out that ball inside of it? Yeah. So fish don't exactly see the same way we do. We definitely see things a little differently. Fish have what we call a lens in their eye, and it's a tiny ball. And what they do is when the lighting is changing, they will bring that lens forward and backwards in their eye to help them focus on what's going on. We can't do that. Our pupils will get bigger if it's darker, different things like that, but we don't really have that ability. So it's really cool that they have that function. And again, it helps them see in lighting. So again, fish don't really rely on eyesight as much as we do. So it's really just important that they can just see the change in the lighting. Here is the lens of the eye. As you can see, it's very, very tiny. It's very small, but again, they pull it closer towards their eye and further back. You guys see it's very, very, it's very small, and it makes a pretty loud clack when it hits. So it's very, very hard. It kind of reminds people of a marble when they see it. All right, guys, so that is the end of our fish dissection. I hope you got to see some really cool stuff. We got to show you some cool things. Go ahead and keep filling out that worksheet. Again, we didn't really find anything in the stomach. The scales on this one's going to be very hard, so you can kind of leave that one blank. That's totally fine. Or you could write cycloid and ctenoid because your bony fish definitely have those scales. So either of those is a good answer. Again, guys, thank you for tuning in. Our next lesson is on Friday, and it's all about sharks. And you have those create your own fish worksheets as well. Big thank you to Captain Mike at Island Time Charters for cutting into this fish for us and letting us learn a little bit more about it. All right, thank you, guys.